you. Actually, going around the room as you were introducing yourselves, my professional and even personal life is so closely intertwined with so many of you. Serving with some of you on the Education Foundation boards and CT advisory for Manassas City Schools, Prince William Schools, Manassas Park City Schools, involved with George Mason University on the SciTech Campus advisory. I've just come back from a fabulous holiday lunch, being on the Nova College board, just being involved in the community, because we cannot do it alone. What you see, and Rick is going to talk about the meat of the whole presentation today. He'll talk about the expansion. You will see we are not operating in a vacuum. We need partners, and we'll get to that. So you've all heard about Micron. How many of you know what actually Micron makes? What do we do? All right. So I think what we are going to do, because sometimes I get even groups that come to Micron, they think we are an IT company, and that they don't realize that we are a manufacturer. So I really wanted to speak about who we are, where we come from, so that you can understand where we are going. So we were founded back in 1978 by two twin brothers. One was a lawyer, another one was an engineer. And they founded a company in Idaho, in Boise, Idaho. They got an investment from a potato farmer, Mr. Simplot, who actually, struck a big deal with McDonald's, and so, he grew rich overnight, and he believed in these guys. He invested heavily, and the rest is history. We just celebrated our 40th anniversary in October. We are the second largest semiconductor company in North America, and sixth largest in the world, and second or third largest memory maker in the world. We keep, switching place with Hynix, which is a Korean-based company, and Samsung is actually the largest manufacturer of memory globally. So we are ranked number 150 on the Fortune 500 companies. Our revenue, which actually for the fiscal year, which ended for us at the end of August, was over $30 billion. We have more than 33 employees globally. We have 12 manufacturing sites globally. We hold over 20,000 patents that are actually in use. So it's not just on a paper. We have the largest portfolio of memory and storage solutions. You'll hear about that. And we provide our chips, our products actually go into all these different segments: compute, consumer networking, storage solutions, automotive, and industrial. So as I mentioned, we are global. These are some of our manufacturing sites. So in Utah, in Virginia, in Idaho, we now have more R&D, research and development facility, not as much manufacturing. Our other manufacturing sites in Singapore. Then we have some R&D and some quasi-manufacturing in California, Taiwan. In China and in Malaysia, we have something what's called back end. They get the products that we make here, and we send it over there, and they cut it up, and actually, it goes then to the final customers. And another manufacturing site is actually in Japan. So back in 1980, there were dozens of companies that were manufacturing memory. And when we fast forward to today, how many do you think are still in existence, or how many of them who may still be in existence are still making memory?
About a third.
7, 15?
Yeah.
3. You say that with such certainty.
3. So memory in terms of DRAM. So between the three of us companies, we have 95% of the DRAM memory market. And we actually make all of the, we make flash memory, which is NAND and NOR type memory, which is in your flash drives, or when you have a laptop or your cell phone. When the information that is there, even if your phone dies, if the battery dies, it comes back up, the information is still there typically, right? It's not possible with the DRAM memory, but we also make the flash memory, NAND and NOR. But DRAM, is also a huge part of what we manufacture. So our memory goes into all of these different applications. It powers the cloud, right? You know about all the server farms that we have popping up all over Prince William region. Automotive, you will hear Rick talk more about that one. Industrial, medical, business enterprise, wearable devices. Chances are, if you wear, any device on your anywhere on your body, it's got Micron memory in it. If you have a GoPro camera, it definitely has Micron memory in it because we provide 100% of all the chips in there. And in consumer applications, mobile. If you have driven a car here that is younger than maybe 8 years old, chances are there's Micron memory in there. It was made in Manassas. And this is what Rick is going to get to. He's going to talk about why really we are growing, because this is true for our site here in Manassas. This is what powers us. But I will take a liberty, because I understand we have about 40 minutes total for this presentation. So I'm going to play you a 4-minute video of really how chips are made and how we make solid state drive.
Take the lens filter off.
Oh, it is. It is. Got it.
There we go. There we go.
Yes. So this is what it looks like inside of a clean room here in Manassas. Everyone wears bunny suits, and it's a state-of-the-art facility. The air is cleaner than air in a surgery room where they would do, let's say, open heart surgery, right? You don't want all the little dust particles in the air, and it's even cleaner in these clean rooms. Now this is already happening in the back-end facilities where they take each individual chip from the wafer and then they encase it. Let's trust that I'm not going to switch it from anywhere. We'll need to go back to the presentation. And Rick is going to pick up and he'll share with you about our site here, Micron Technology Virginia, or MTV, and why we are able to expand.
So while they're dealing with the technology there, I'll let you know a little bit about myself. My name is Wingo. I'm the site finance director, also have the controller responsibility underneath me. And I actually go back quite a bit further than I mentioned in my introduction, quite a bit further than this operation. Some of you may remember a company called Dominion Semiconductor. In 1995, I got a call when I was down in Raleigh working for IBM from a colleague of mine. He said, we're going to start a semiconductor operation in Manassas, Virginia. Would you like to join? My first reaction, I've been pretty much a lifelong member of living in Virginia, was Manassas of all places is not where I would envision this starting a memory company. But the rest is history. The relationship was with IBM and Toshiba. IBM stayed on for 3 or 4 years. When they left, Toshiba took over. They later partnered with SanDisk on a NAND project, and in 2002, Micron stepped in and bought out the DRAM operations, moved the NAND operations to Yokoichi, Japan, and I continued on in that capacity as a site senior finance manager, and to this day. So I've seen a lot of change. To give you perspectives, as Rana talked about, showed you some of the information here about how a semiconductor is made. Just to give you an idea of how expensive that is, and by the way, behind every good engineer is a good finance person. I happen to be that person. But one photolithography tool, which is arguably one of the most technically challenging parts of the manufacturing process, is upwards of $100 million a piece, just for one piece of equipment. So you roll that all together, and you get an investment here that averages anywhere from $3 billion to $6 billion, depending on the facility and where it's located. So an awful lot of dollars and cents goes into that. So let's start with a little bit of an overview of, we call it MTV, Micron Technology Virginia. As Susanna mentioned, we have facilities all over the world. The one in Virginia here is primarily focused on memory associated with the automotive industry. And as she mentioned earlier, roughly the statistics are 1 out of 2 cars that you would probably drive in the U.S. is likely to have memory from this plant. And the expansion that we'll talk about in a second was designed to facilitate Micron staying in the leadership position in the memory industry for automotive. You'll hear a little bit later discussion about an engineering development effort here in addition to the manufacturing, which is going to bring together technology from not only Micron, but potentially from other companies and universities in the state of Virginia together to look at future technology development activities. But MTV joined the Micron family in 2002. As I said, at that time, Toshiba was running the operation. Micron stepped in and bought the DRAM operations, most of which end up in PCs and that type of thing. Eventually brought in NAND and NOR. We'll talk about that in a second. We are the first 300 millimeter site for Micron. So what? What is a 300 millimeter site? 300 millimeters is roughly 12 inches. It used to be much smaller than that, about 40% smaller. There's some talk about going from a 12-inch maybe even to a 14 or 16-inch, but that's probably quite some time down the road. But we were the first site to have that 12-inch capability. Soon, within 5-6 years thereafter, we were one of the smallest operations in the company. Most of the bigger facilities now are in Singapore, and Japan, and in Taiwan. But we all run the 300 millimeter set. 1,300 team members, on and off, 200 contractors. That number of contractors is about to skyrocket. With the expansion, you'll see hundreds and hundreds of contractors here. In fact, we're having a great challenge today finding places to park because the contractors are on the same facility where we are, and we've had a lot of angst there in trying to find places for people to park now because of the number of people that are going to be there. DRAM, NAND, and NOR. Again, DRAM you find a lot in PCs, NAND you find a lot in iPhones, iPads. The difference between the technologies is NAND tends to hold information even after you turn the machine off, whereas DRAM, once you turn it off, you lose the information that's saved. NOR is kind of an interesting product. Those of you who've been to Japan or kind of dabble in travel, in Japan they have what they call pachinko machines. They have pachinko parlors, which are gambling parlors. Some sophisticated electronic machines that they use for gambling. That's what the NOR product goes into, among other things. That's one of the biggest customers is Japan for pachinko machines. 40 part types. Again, why is that important? Most of the other facilities in Micron, you'll see a couple of part types that they manufacture. We not only manufacture DRAM, NAND, and NOR, but we manufacture 40 part types within that. So we have arguably the most complex operation in Micron, and not just Micron, but also if you look across the world at technologies for memory. This is one of the most sophisticated memory operations in the world, even across Samsung and Hynix. So it's a very sophisticated operation. 173,000 square feet of clean room. We'll talk about that in addition to in relationship to the expansion. We're going to build out the first expansion is about another 100,000 square feet. Just to give you an idea of how much that costs. A memory facility worldwide averages about $3,000 a square foot just to build the facility. And that's not just the price of the equipment, which I mentioned to you earlier, is quite expensive as well. And we're one of the top one or two, depending on when you define that, exporters of Virginia in terms of product value. All right, expansion, phase one. As I mentioned, 1996, this facility was first built when Micron took over in 2002. We added capacity considerably at that time. We were adding NAND to the DRAM product mix. This expansion, it's going to be in two phases. The first phase is 115,000 square feet of clean room space. That'll increase our production capacity dramatically. And there's a plan for a second phase, which we'll show you the calendar for in just a second, that's going to be equally that large. So it dramatically improves the throughput. One thing I'll mention on the financial side, at the end of the day, it's all about economies of scale. When you're building memory product, because you've got an investment like we do, in this case, $3 billion or more, it's all about output. As you get more output, you get lower cost per unit. And at the end of the day, that's one of the reasons why when my colleague asked me if we want to start a facility up in this part of Virginia, even with the economies of scale they were talking about, it's still rather expensive to manufacture in this location. We've made up for that, in this case, with this expansion by getting tooling from other facilities within Micron, which dramatically lowers our cost structure and allows us to compete with some of the best in the industry at a very profitable clip. This is to the right. The existing facility there is on the left, the dark building ceiling. This will be the new facility. The facility itself, the manufacturing facility, is this white building at the bottom, and then the support facility. There's a huge infrastructure there with electricity and water and gases and so forth. They call it the central utility plant, which is right behind it. The facility that's being expanded is going to be much higher than the existing facility, and primarily that was because to save expansion costs because of the footprint that was underneath the fab being a lot of rock and heavy sediment. Also because anytime you do construction activities or any kind of activities around an existing fab, vibration is a killer. Just small vibrations in the fab can cause some of the microelectronics and processing just to go haywire. So this is going to be more vertical than subsurface, and in the process saving us a lot of money as well to make that. In addition to the expansion, which we're going to spend in both phases total about $3 billion of expansion costs, there is some effort to establish a global center for excellence associated with what we call long life products. Sometimes you'll hear a reference to this facility here producing older technologies. Let me tell you that the automotive industry is not like the space industry using state-of-the-art technology and memory right now. A lot of the memory that is produced in those products doesn't require the same kind of tolerance and sophistication that some of the memory like in the spacecraft, for example. But we are going to be partnering, as I mentioned, with some of the local universities in Virginia, as well as some other technology groups, to bring in a group of technicians and engineers who will be studying future applications for automotive and those kinds of applications. So even though automotive isn't at the leading edge in terms of using sophisticated technology, the technology in cars is becoming more and more sophisticated, and the memory that's required for that is most of the memory that we make. So a lot of opportunity there. Dr. Fuller, some of you may know him at George Mason, has done a lot of economic studies. We engaged him a couple of times to do some studies on the impact of the Micron facility in the local and state economy. This is some of that information that he pulled together As I mentioned, depending on when you're looking at it, we've been the top 1, 2 in terms of export value of the products that we export. And Virginia, of course, it wasn't too long ago, less than a dozen years ago, that Virginia was all about agriculture, and still is, but in terms of actual throughput in dollars, technology now has taken the lead there, and within that, memory is arguably the largest portion of that for the state of Virginia. A lot of high-tech manufacturing jobs. We employ about 1,300 currently. We'll be adding another over another 1,000 in this expansion. And the data here on the contribution to the Virginia economy is our information that was put together by Dr. Fuller. As you can see, the multiplier effect of having people here who contribute to the economy, who in turn drive other services, is certainly a powerful influence on what goes on economically in this region. And the providing high-wage skilled jobs, the expansion is going to be largely engineers with a lot of technicians as well, but they're all very high-paid jobs. And as you can see from the bottom, this is in the 2017 study. The average for skilled jobs here was about $85,000, and even higher than that in the expansion. So we're bringing in a lot of high-tech, highly qualified, in many cases very highly educated people to the region on top of the base that we have today. $3 billion investment for the expansion, about half of it by 2020, that facility I just showed you, and then an almost identical facility will be next to it, which will be the second $1.5 billion by 2029. And the jobs associated with that were roughly 50-50. The first half by 2020 would be 550 people, another 550 by 2029. So it's a very, not only is it a large dollar investment, it's a large people investment as well, and all the supporting infrastructure that goes with that. And I also mentioned the average salary. You saw what it was in 2017, $92,000. Expected to climb at a roughly 3% annual clip as we begin the new phases of activity. And recruiting is extensive. Obviously, we want to try to do as much of that as we can within the state of Virginia. Susanna will talk a little bit about that as well. But most any of the local and the regional, certain state universities that are here in the state, we touch at some point and hire and recruit very aggressively from as well. So we're not only that conduit from an education standpoint, but from a job career standpoint as well. And the donations, as Anna will be talking about this as well. The Micron organization is a big player in education, STEM, and other applications, as Anna will talk about. But also from a contribution standpoint, the Micron Foundation has been a very big player in this part of the country in terms of education to the local economy and infrastructure there. Okay, let me turn the time over to Susanna. Before, any questions about the dollars and cents? The finance guys didn't get out too much, so appreciate it. It's a big leap for us. We were competing with Singapore, Taiwan, and Japan for this facility. Well, the punches by saying that this wasn't a simple decision because there were a lot of talking about scale economies and cost structures. It's hard to beat and challenge that of the environment overseas, as many of you know from different other industries and see how companies have offsourced, offshored, if you will. But the reason that we got this here was because of not only the relationship with the local economy, city and state, but also the rich opportunity to hire people coming from universities and the local economy that just doesn't exist anywhere. And then fundamentally, we were able to leverage some of the investment within the company for this facility and do it at much cheaper costs. So we're real excited.
Education question. What majors would you be looking for? Is it engineering majors or is it like the university?
And I will have more specific in the slide, but it is, engineering degrees, and also it can be an associate degree or just a certification, for the technician population, or equivalent skills, yes.
Any other questions? Yes.
I know you participate in STEM programs within the community, but what specific partners do an example of the partners that you partner with in the community?
Absolutely. Manassas City Schools, Manassas Park City Schools, Prince William County Schools, and specifically their career and technical education on the statewide level, CTE as well, and workforce development board, Northern Virginia Workforce Development Board, the Northern Virginia Community College, and then also here in Manassas ECPI University. We also work closely with the AIM, it's the Aviation Institute of Maintenance here in Manassas. We work closely with Germanna Community College, Fort Fairfax Community College, and actually expanding into John Tyler and other community colleges throughout the state. And as far as universities, George Mason University and UVA, Virginia Tech. We have ODU, Old Dominion University, VCU, VSU, Virginia State University as well, Norfolk State University, and some others. But the universities that I mentioned, they have very robust engineering schools, engineering colleges, so we are really, attached to the hip with them. I mean, we just really, we serve with them on various advisory boards. We mentor their students, their capstone projects, senior design projects, invest in their labs, in their clean rooms, and bring them here for tours, to our site, do different lecture, technical presentations to them, presentations on leadership, in the engineering workplace. For us to really find the talent, we have to, as far as engineers, unless it's for some specific, degrees, such as in like data analytics, which those are fairly hard to come by. It's fairly easy to find engineers, if you will, with the degrees that we need. What we need to really work on is the technicians, is the technician population. And we'll talk about it a little bit more.
Okay. Thank you.
So understanding is kind of when corporate was talking about expanding Micron, that Virginia wasn't on the horizon. They weren't being considered with the leadership team out here locally. That when to really start to advocate for the expansion here. You kind of both alluded to it, but really when you're going through that process, what was it that key critical issues that said, all right, it is going to be Manassas, it's going to be Virginia, and here's why. What helped you get over that hurdle where we're not going to expand in the States or in Virginia, much less, but you guys got them to...
It was a combination of things, not the least of which was we had a state government that was willing to partner with us from an investment standpoint, as well as the city. We've had a long live relationship with both entities, and there were similar kinds of structures in Singapore and in Japan that we were competing with. But I think that the longevity of our relationship has been outstanding, and that was a key contributor. There were some technical things inside the company that also were favorable for us. The memory business in the automotive industry was expanding so quickly that we had to find a place for the additional supply to meet that demand. It just so happened that we were at the right place at the right time to be seriously considered because of our existing cost structure. And we had developed a model over time where we would bring in the equipment from other locations as they rolled that down. So we could cut our investment easily by half or more. But the relationship with the state and the city was crucial because at that time we were also looking for some assistance on the investment side to get things going. So and of course the education environment, the resource environment for engineers and technicians was key. Right.
What was that 3,000 number used? Was that a build-out cost, or what was that again?
$3 billion.
No, I thought you said 3,000 per square foot someplace.
Oh, that's an industry quote that I just read this morning about what the average cost to build a facility is in worldwide. Average cost per square foot. Now that's just the facility. That doesn't include all the equipment inside of it.
And does that include the clean room space, or is the clean room space included in that?
Right. And that was a semiconductor reference. It wasn't specific as much to memory. Memory is actually a little bit higher. Yes, ma'am.
You said November for the groundbreaking. Is that this past November, like a month ago, or is that in 2019?
Just a month ago.
Just a month ago.
Right. It's going to take about 18-ish months to finish the facility, and the tools will be rolling in.
So I'm just going to play it. 3 or 4 minute video on Wingo. Also hoping to get a parking deck there somewhere in the parking lot, so we have a place to park.
They're filling up their parking space.
So I wish it would be so easy, right, to build a building. It looks very smooth and not messy. All right, so we cannot do any of this that you just heard about. We cannot achieve it without qualified technical workforce. And that's why we really need the partners, the communication partners, in the K through 12, and then in the higher education world. But here in Virginia, this is just a little bit about our team members. We live pretty much, there's a largest concentration here in the Prince William County, in the city of Manassas, but we are pretty much spread out. I know some team members live as far as Richmond. The map doesn't go that far. We have a few team members living in Maryland. Some live as far as West Virginia, but kind of the highest concentration. We are very diverse, but this is not a surprise. I mean, we have like at George Mason University and at Nova, 170 different languages. We have only 55, right? But still very. You hear many accents like mine there. Even though some of us may have the citizenship, even though citizenship is not required. We are not a government contractor, so we can bring in students who are here on student visas, but also residents and others. We are courting some government contractors, the DoD and etc. But we don't have the requirement yet. We are not like, I get these questions all the time, are you like Lockheed Martin next door or like BAE Systems? You know, not exactly, even though we do business with Lockheed. We sell our solid state drives for their submarines and for other applications. But so the two most common technical position levels that we have in tiers are technicians, which require either a 2-year degree, it can be AS, the Associate Science, or the AAS, the Applied Associate of Science degree, or it can be just an industry certification. It can be like automotive technology, aviation maintenance, electronics, mechatronics, or military experience. We are very heavy into recruiting from different military bases, recruiting veterans, and these are the related field, you know, that I mentioned. Engineering technology is a part of it also. We have partnered with Nova, and they will be opening up a new mechatronics program, mechanical and electronics, mechatronics, building a fab lab or fabrication lab at the Manassas campus. And they have also partnered with other companies in this region too, and they have built an AAS degree based on the feedback they have received from companies such as ours and from also the server farms, what they need in their technicians. We have also started, we had to get creative because we couldn't really find the qualified technicians, and we started a technician internship program, which is a co-op program really, because they have to be with us for 9 to 12 months in length. We bring them in as they are enrolled at a community college or technical school. They work 40 hours a week, flexible, you know, because we never close. We are open 24/7, so we can be flexible with their schedule. They can still take some classes. They get paid as if they were, you know, full-time technicians. We also offer health benefits to them and 5% of 401k, so there are some benefits there. And we have converted more than 75% of them into full-time positions. So about out of 125 in the last 5 years, 75% of them are still with us. And now we have expanded the program into even more co-ops. So that's been our major source of technician talent. But we also hire, you know, into the full-time technician positions right away. Engineers, electrical, chemical, mechanical, material science, computer science, optical engineering as well, big data, and industrial engineering. Any question about the actual workforce and the talent?
I'm curious what the average wage difference is between a technician and an engineer.
Right. So we have, you know, the technicians are actually hourly, so they get paid hourly and they can make overtime. So, you know, we start them around $20 per hour, and of course, you know, it grows into, you know, the 30s or so. And with the engineers, they typically start in the mid to upper 20s, 20s, you know, per hour equivalent, but they are salaried, so they don't make, you know, overtime, if you will. And then there's, you know, company profit sharing and, you know, various other benefits. Education assistance, so we pay, you know, to our employees, we pay education assistance. It's approximately $5,000 a year for undergraduate degree and about $7,000 for a graduate degree when they are with us. We also have free membership into the Freedom Center, you know, which is an awesome benefit that we very much appreciate. So in the community, Rick mentioned the Micron Foundation. That's really how we are able to donate a lot of funds that stay here, most of it in the Prince William region, in the city. And we encourage our team members to volunteer. We also send teams out for team building activities to help, you know, if it's at a food pantry or if it's, you know, with Project Mend the House or Habitat for Humanity. But mainly it's with robotics, with different, you know, STEM days, different career days. And this is something I wanted to encourage you to participate in as well. We partnered up with the Education and Innovation Committee here at the Chamber. And when schools have different career days and different breakfasts with, you know, businesses with careers, such as Osborne High School has just recently, last Friday, had one, that we encourage Chamber members to sign up, go there and share with the teachers and with the students about the different careers you have in your respective businesses, just so that the students can see themselves, you know, as they can see their possible future, and they can take courses and industry certifications while they are still in high school, while it is on the dime of the state or the federal, where they use Perkins grants. because once they graduate from high school, they are on their own, right? So if students are kind of lost in high school years and don't get those certifications for free, then they have to pay on their, pay for them on their own. And I've run into so many high school graduates, from this region who are like, well, I didn't know I could take that automotive certification while I was still in high school. I didn't know that, or if they would only knew. So come with us when it's promoted. This is a little pitch. You will hear more about these activities and the partnerships that we have with the CTE on the local levels as well as on the state level. But it takes a village, so please come yourselves or send your colleagues to share with the students where they could go to help motivate them. So this is just some of the partners that I talked about. We started actually on March 1st. We really started tracking volunteer hours of our team members, and we are now at 129,000 hours that we've logged in. Micron actually gives us 16 hours a year to volunteer, to actually go on our own and volunteer, and then when we go as teams, that's even more so on company time, when a manager takes you, if you will. All right.